As continuation of earlier episode, today we will discuss the effect of center of gravity in case of packs and also the solution. To begin with, we can go through the definition. Gravity is a fundamental force of nature that attracts objects with mass toward one another. It causes objects to fall to the ground when dropped. The center of gravity, CG, is a specific point in an object where its weight is balanced. When we drop an object, all parts of it experience the force of gravity, but the CG is where this force is concentrated. Importance of knowing: the CG is crucial for packaging, especially for heavy or delicate items. If the CG shifts, like if the weight distribution changes, the package can become unstable and might get damaged. Here is one example with weights. Imagine a package with weights at 3 points. Point A, 4,000 gram. Point B, 5,000 gram. Point C, 6,000 gram. To find the total force acting on the package, resultant force, R, is to add the weights together. R is equals to 4,000 gram plus 5,000 gram plus 6,000 gram is equals to 15,000 gram. Moments, M. This tells us how the weights are affecting balance. For example, the moment around point C, moment M is equals to 4,000 multiplied by 30 centimeter, where 30 centimeter is the distance between point A and C, plus 5,000 multiplied by 15 centimeter, where 15 centimeter is the distance between point B and C, plus 6,000 multiplied by 0. The total is 1,95,000 grams per centimeter. Finding distance denoted as N to see how far the resultant force acts from point C. The formula is N equals to M divided by R. Hence, N is equals to 1,95,000 grams per centimeter divided by 15,000 grams is equals to 13 centimeter. This means the resultant force acts 13 centimeter away from C. By the same method, you can calculate the resultant force from point A and point B also. What happens when a packed product falls? When the package drops, it accelerates downwards at about 32.2 feet per second square, which is gravitational acceleration. You can calculate how fast it goes when it hits the ground using formulas based on initial velocity and time. There are also forces after impact. Acceleration: while falling, the package accelerates due to gravity. Deceleration: when it hits the ground, it doesn't stop instantly. It slows down, which is called deceleration. Example of impact force: let's say a package weighs 500 grams and drops from 70 centimeters. If it compresses by 5 centimeters when it hits the ground. Force: during deceleration, F is equals to 500 multiplied by 70 divided by 5 equals to 7,000 grams. Total force exerted is equals to force F plus the weight of the package. Total force is equals to 7,000 plus 500 is equals to 7,500 grams. This means the force during impact is 15 times its normal weight. Packaging considerations. When packaging fragile items: number 1, cushioning. It helps absorb shock and protect the items inside. Number 2, weight distribution. If you have both heavy and fragile items together, you need to make sure the fragile parts are protected from impacts. As a packaging technologist, you should consider the points to avoid any physical damage of pack. which will result to returning of goods back to manufacturer as a loss. Number 1. Understand where the center of gravity is to prevent damage. Number 2. Use good cushioning materials to limit shock during impacts. Number 3. Consider how different weights and forces interact to create safe, effective packaging. By paying attention to these factors, you can create packaging that keeps items safe during transport. Please like, comment, and subscribe our channel Packaging Buddy to get such information in coming sessions.